In this example, ThermoFlo software is used to study the flow of water in a pipe system. The problem involves pumping water to high levels of a building. Note that the problem can be solved in any direction that the user chooses. In the first scenario, let's say we want to deliver 4 kilograms per second of water to the 20th floor, 100 meters high, through 1,000 meters of 5 centimeter diameter cast iron pipe with a roughness of 0.26 millimeters. Knowing the various losses in the pipe system, we want to determine the pump power required to deliver this flow, assuming an efficiency of 80% for the pump. Start ThermoFlo, then click on Create Model, give it a name, for example pipe_complex, and then we click on Save. Now we choose thermodynamic cycle, and from the components we choose pipe, drag and drop it on the canvas. Now we take an endpoint, place it at one end, and we take another endpoint and put it on the other end. Connect the components, right click on any connection point and set to fluid. Water is the default, so we keep it that. Now we double click on one endpoint, define inlet, give mass flow rate of 4 kilograms per second, set pressure to 1 atmosphere, temperature to 20 degrees Celsius. Apply to define it. Double click on the other endpoint. The only thing we need to define here is pressure. We make it 1 atmosphere. So there's no change in pressure. Now we will double click on the pipe to give its properties. We set the diameter to 5 centimeters, length to 1,000 meters. Now we check the pipe losses on and enter the minor losses 9.5 and give a surface roughness of 0.26 millimeters. Click on Advance. We uncheck pump power because we want to calculate it. Give the pump efficiency to 80% and we set the height change to 100 meters. Press Apply and we're ready to run the problem. Click on Run and get the results. Now we open the out file to look at the detailed results. The endpoint calculated results are written. Notice that -999 means liquid, compressed liquid. Velocity, area, everything is calculated. And then we look at the duct results, and all the calculated results are there. Pump power is calculated to be 1,159.2 watts. As I mentioned earlier, this problem can be solved for any number of unknowns. We can solve for the pipe diameter, height change, surface roughness, pipe losses, velocity or mass flow rate in the pipe by simply unchecking what needs to be solved for. To demonstrate this, let's look at scenario B. We want to determine the mass flow rate of water that can be maintained by a pipe system using an 11.6 kilowatt pump with the efficiency of 80% to deliver water flow to a height change of 100 meters through 1,000 meters of 5 centimeter diameter pipe, knowing the losses in the system. First double click on the pipe, then we go into its properties, turn on the advanced properties. We'll check the pump power to enter 11.6 kilowatts. Press Apply to save the properties. Now we double click on the inlet and we uncheck the mass flow rates because we want to calculate it. Now you press run to solve. Now we reload the results. If you look in the out file, we can see the results displayed as before. Mass flow rate is calculated for the pump work of 11.6 kilowatts to be roughly 4 kilograms per second.